Hey, hello and welcome. Today I'm going to be introducing Firebase to you, and we'll learn how to build a REST API with Firebase Cloud Functions, TypeScript and Firestore. So prerequisites for this course is knowledge of REST APIs, knowledge of TypeScript, and knowledge of the Express.js framework. Now we are in the Firebase homepage, and you can access Firebase homepage by navigating to firebase.google.com on your URL address bar, or firebase.com, or you can search for Firebase on Google and that should be the first thing that shows up. We have a Firebase homepage, and depending on when you open this homepage, it'll look really different because currently Firebase has a CSS problem, and look at that. That's why I've highlighted this so that we can see the text. Firebase helps you build and run successful apps backed by Google and loved by app development teams from startups to global enterprises. So our application is going to be a serverless application. And what does that mean? There's not much difference between this and what you've been doing before in terms of building REST APIs. The only difference is that now we wouldn't have to worry about managing the servers, setting up and running servers, and paying upfront for a particular period of months or years and all that stuff. We won't have to worry about what goes on with the servers. All we need to worry about is the development side of it. So Firebase Serverless Applications is not taking away backend jobs. We are still doing the development side. If it's taking anything, it's the DevOps part, but that's still needed because someone has to set up all these things. So it's just making our lives easier. It's not taking anyone's job. And that's what serverless is. We can easily develop scalable and high quality applications without worrying about the cost of setting up and maintaining servers for a long period of time from the onset. That's what serverless applications are. And we'll be using Firebase as our serverless application solution. Now we'll click on the Get Started button to get started. When we click on this Get Started button, we should be taken to the Firebase Console, and you can access the console directly by navigating to console.firebase.google.com. Now on the Firebase Console, you probably see something different because I'm guessing you've not created the Firebase project before. So if you're new to Firebase, if you've not created a project before, you see a different interface from what we have here. And then another thing I'd like to point out is I'm signed into my Google account. So once you have a Google account and you're signed in, you wouldn't need to register or sign up for Firebase. You have a Firebase account automatically. Right now in the Firebase Console, no matter what you see a button that have a text with an information similar to this: Add Project. We click on the Add Project button to add a new Firebase project. This is where we want to store our cloud functions. Cloud functions are similar to controllers in your REST APIs. Not much difference again, and we'll see what we're talking about here. Let's build our project. We'll start with a name for our project. Now we can write whatever name we want inside here. Our application is going to be a journal REST API where we can add entries. We have a journal or a diary where we can add different entries daily to our journal. Our entry will be made up of title, text, and maybe we can add another field, a cover image URL. So we can post title, text, cover image URL to our database, and we'll be using Firestore, a database from Firebase, to manage data in our application. We can use any name for our projects here. Right now I want to go with REST API journal. Okay, we can see that. Now project name can be anything, but then there's also a project ID underneath the project name, and that has to be unique. So if REST API journal has not been used before for a project ID, we get that here where the project ID is supposed to be, beside this pencil button. But if it has been used before, let's say we want something like journal, and yeah, looks like someone has used that before. Look at that. So we have an extra string which is being suggested for us. We can decide to change this to something else, but it has to be unique. Let's go back to what we had before. REST API journal should do, and you click on the continue button to create your Firebase project. Google Analytics for your Firebase project. Firebase offers easy integration with different Google services like Google Analytics, Google Ads, and so on. We click on continue for this. You might want to enable it, you might not want to enable it. That's your choice. Choose or create a Google Analytics account. If you did that, you click on the default account for Firebase or create a new account. Then finally create projects to create your Firebase project. Look at that, your new project is ready. Click on the continue button to continue. Now we've been taken to our project overview page. We see that we have a new project created for us, REST API journal, and we're currently on the Spark plan. This is the default billing plan for Firebase and it's free, but there are different limits to this particular free plan. We want to be using the Cloud Function service from Firebase, and when we click on this functions part, so we see that on the left hand pane there's a develop section. If you don't have that open, you see develop quality or analytics. You click on develop and we have authentication, Cloud Firestore, real-time databases. So these are the two different databases that Firebase offers, the Cloud Firestore database and the real-time database. What we're going to be using for our application is the Cloud Firestore database. Now we click on functions to get started with our Firebase functions, and you can see here, run your mobile backend without managing servers. To use functions, upgrade your project's billing plan. So we can't use functions with the Spark plan. We'll have to upgrade our project's billing plan to the Blaze pay-as-you-go plan. Now when we come over to the prices section of Firebase, or we can compare the different prices for the different plans. And for the free plan, the authentication service is 10k per month. Cloud Firestore, we have 1 GB in total for the free plan. Network egress document rights. You can come over here and see the different comparisons for the different services for these different plans. But for Cloud Functions, see that it's limited to Node.js 8 runtime, which has been deprecated in Firebase, and that is why we don't have the option to use Node.js version 8 in our Cloud Functions. Before now, that would have been possible. We could go with Node.js version 8 and we'll be able to use Cloud Functions with the Spark free plan, but version 8 has been deprecated in Firebase. We'll only be able to use version 10 of Node.js or version 12 of Node.js. So when we come back to the Firebase pricing and go over to the Blaze pay-as-you-go plan, let's see what we have in Cloud Functions. Now this is similar to the Spark free plan, just that when we get to a particular limit, when we've made a particular number of calls to our APIs or use a particular amount of data in our database, then we'll start getting billed. So look at this. For Cloud Functions, Node.js 10 or later runtimes require the pay-as-you-go Blaze plan. So for invocations, free for up to 2 million invocations per month, then $0.4 per million invocation. So we'll need the Cloud Functions. But the good news is that we're not going to spend up to $0.1 right now in setting up our Firebase application and using this journal REST API that we'll be creating. So don't worry about price right now. What you're going to do is click the upgrade project and then you'll be asked to provide a credit card. You'll probably get billed like $0.1 or a really small amount of money. For my account, I've already set up a credit card, so I wouldn't need to do that again. See that we have an info here. You will now be charged based on your usage of database, storage, hosting, machine learning, test lab functions, and Google Cloud services. Click on purchase to continue. We have the Blaze pay-as-you-go plan. Now you can set a budget alert. I like setting a budget alert for $1, so I would know once I start getting billed and do whatever I want to do about it. I think you can set for like $0.5. Yeah, you can set for like $0.5. You can set for less than that or more than that. So for this demo, since you're building a demo application, please set a budget alert for a very small amount of money so that you know when something starts going wrong or in a way that you did not expect. So we set our budget alert. And we have that. You've successfully upgraded your project. Click on the close button. Now that we've upgraded our project, we can use the Cloud Function service of Firebase. The next thing we'll be needing is the Cloud Firestore service. So this is the Firestore database for Firebase. We have the Cloud Firestore real-time updates, powerful queries, and automatic scaling. It's a NoSQL database for mobile, web, and server development, and it offers a seamless integration with Firebase Cloud Functions. You'll see how straightforward that is. Now to create a Firestore database, all we need to do is click on the Create Database button, and then we should see a pop-up, Start in production mode or Start in test mode. Now for production mode, your data will be private by default. Client read/write access will only be granted as specified by your security rules. And for test mode, your data will be open by default. So what I like to do is always start in production mode. For test mode, anyone with your database information can read and write to your database. But for production mode, we'll need to create a security account and provide access to different people. Now, we'll start in production mode so that I'll show you how to access your database through your security rules. Now we start in production mode and we click on the next button. Your location setting is where your Cloud Firestore data will be stored, so I like to go with the default and then click on enable. Now we have a Cloud Firestore database for our Journal REST API project. Now that we have our Cloud Function service set up and the Cloud Firestore database set up, let's write our first Cloud Function. To start writing our Cloud Functions, let's navigate to a project directory of our choice in our file manager or via a terminal, and then we open the terminal. I'm going to be using git bash, so git bash here, you can use any terminal you want. With our terminal open, the first thing we're going to do is confirm that we have Node.js installed. So to do that, that's nodes -- version, and see that I have Node.js installed. If this returns an error message, then you can install Node.js by going to google.com and searching for Node.js. Try to install version 10 since this is what we'll be using for our Firebase Cloud Functions. So when we come back to the Firebase Cloud Functions page and click on the Get Started button, see that we have an instruction here. To use functions, you need to install Firebase command line tools using npm. So once you have Node.js installed, you'll have npm installed too. The Node.js installation comes with npm. Now we can copy this command and paste it in our terminal. Click the enter button and we should have the Firebase tools installed. Since I already have the Firebase tools installed, I'm just going to cancel this. And now that we have the Firebase tools installed, we can decide to create a new directory for our project. Let's say we want to name this REST API journal. We can now use the command Firebase login to log into Firebase on our terminal. We run this command and we should be taken to a browser where we can complete the authentication. I'm already logged in, so you can see this, already logged in as ebenezer.official@gmail.com. Now that we have the Firebase tools installed and we've logged into Firebase on our command line, we can now create a new Firebase function by running this command, Firebase init functions. Click on the enter button and look at what we have here. You're about to initialize the Firebase project in this directory. Are you ready to proceed? I'm going to click on no because I've not changed directory into the new one we created. So I'll click on no to cancel, and then the next thing I'm going to do is cd into the new directory we created, and that's REST API journal. Now that I'm in REST API journal, I can now run the Firebase init functions command again. Are you ready to proceed? Y for yes. And look at what we have here. First, let's associate this project directly with the Firebase project. You can create multiple project aliases by running Firebase use add, but for now, we'll just set up a default project. So if we had not created a project from the Firebase console, what we'll do is navigate to this create a new project option, but we already have an existing project. So click on use an existing project, and now we have different suggestions from our Firebase project. So the Diary App API, Journal Diary API, REST API journal, and Social Ebenezer. So we are just going to use the REST API journal, which we just created. We select that and look at this. The functions directory will be created in your project with a Node.js package pre-configured. Functions can be deployed with Firebase deploy. What language would you like to write Cloud Functions in? Let's use TypeScript. We select TypeScript, and the next thing we have is, do you want to use ESLint to cache probable bugs and enforce style, or we'll be skipping this for our project. And the next option is, you want to install dependencies with npm now. Yes, we do. Look at that. We've successfully initialized Firebase and Firebase Cloud Functions for our project. Let's open this with VS Code. I'm going to use this codes commands with a full stop. Or you can go over to where you have the project in your file manager. Alright, click on it and then open with code. Depending on whatever operating system you have, just try to open that folder in a text editor like VS Code. So click on the enter button to run the command, and we should have VS Code open up for us. Now here's our code base, the REST API journal. See that we already have default files that came with the Firebase initialization. We have the Firebase RC file, which contains the default configuration for our Firebase. We also have the Firebase.json file. We wouldn't need to be touching all these right now. what we are focused on is this functions directory. And inside the functions directory, you see that we have a package.json file. We don't have the package.json file in the root directory. We have that package.json file in the functions directory. That means that whenever I want to run any of these commands, the build, serve, shell, start, deploy, logs, any of these commands, we will need to navigate to the functions directory of our REST API journal app, not from the root directory. We also have the src directory inside the functions directory, and when we come over to the index.ts file, you can see that we already have an example function which has been commented out. Let's uncomment this so we see it more clearly. Now look at this, start writing Firebase functions, https google.com. I'm just going to make this bigger. Alright, that's better. First of all, we're importing functions from Firebase functions, and this is what we'll be using to create our function. So you can see the first function here, export const hello world equal to functions.https.onRequest, and this onRequest method expects a function as its argument. A function has the request param and the response parameter. The next thing we have is our functions logger that logs hello logs, and then response.send hello from Firebase. Now to test this default function, what we're going to do is go back to the terminal, and then in our terminal we'll navigate to the functions directory. Right in the functions directory, we'll run the command npm run deploy. This should deploy our cloud function to Firebase, in this case our hello world function. Look at that, our function has been successfully deployed. Now to see our function in action, what we're going to do is go back to the Firebase console in our browser, and right in the Firebase console we will load this page. We should now see our first cloud function. That's the hello world function. The name of the function is hello world, and the trigger, that's URL, is this that we can see right here. It has our project ID in it, and then slash hello world. So let's test that out. Amazing, hello from Firebase. So we've successfully deployed our first cloud function, and it works really well. But our application will be a little more complex than what we have here. We would want to use added functionalities like middleware, so we'll be needing the Express framework for our journal REST API. With the Express framework, we can easily manage routing from our code base and use middleware. We would want to use an authentication middleware for checking user inputs, and so on and so forth. So let's see how to set up Express.js for our cloud functions. Alright, to start using Express in our application, we'll come back to the terminal. And remember that we're still in the functions directory. Now inside the terminal, we'll run the command npm i-s express. So I'm assuming that you've used these technologies before: Node.js, Express.js, and TypeScript. So what is new to us is Firebase, the cloud functions, and Firestore. Awesome, we have Express installed. Now we can use it in our application. Let's go back to our text editor. Back to VS Code. What we're going to do right inside the index.ts file is import Express. So import star as Express from Express. I've gotten used to writing JavaScript without the semicolon, so I'm just going to get rid of it. And we have our two import statements. The next thing we're going to do is initialize Express with const app equal to Express, and that's what we want to export from our index.ts file. So we'll take this app variable on line 4, and instead of declaring a new function inside our functions.http.onRequest method, what we're going to do is use app as its argument. And with that done, we don't want to put this in a hello world variable. We're just going to export this from our index.ts file. So we have this export.app equal to functions.https.onRequest app. So this is supposed to be exports. Alright, the next thing we're going to do is add a test route for our Express app. So to do that, app.get, and let's use the base URL slash a comma, and then we have the request and the response. Then where's the status 200 just send hey there. So this is just like building any other Express application. When the user navigates to base routes, they will receive a response, hey there. To test this out, we'll go back to our terminal and redeploy our application. So to do that, remember you have to be in the functions directory and then run the command npm run deploy. Awesome, we've successfully deployed our application. Now let's see what this looks like in our browser. Back to our browser, and in the functions page, you notice that we now have an app function right here. If you don't see yours, you'll have to refresh the page. To test out our application, we'll navigate to this link. So I should be able to go to this particular link and look at that. Hey there. So our function works correctly. Our Express application is working just fine. Now that that is done, the next thing we're going to do is create a service account. We'll use this to access a Firestore database. So let's come back to the Firebase console. And to create a service account, we'll come over to this settings icon, click on it, and then project settings. We'll go over to the service accounts page. Next thing we'll do is create service account. Select Node.js and generate new private key. Your private key gives access to your project's Firebase services. Keep it confidential and never store it in the public repository. So click on generate key and we should have that. So that's downloaded. What we'll do next is open this downloaded file. And then we have our service account details. Now we can pick this file and then put it directly in our project folder. So we can take this file from wherever it is right now. Right now it's in downloads, and then you have that file in the downloads so that we can copy it and put it in our projects directory, then use it from there. But we don't want to do that because we'll be pushing this project to maybe a GitHub account or a public repository. So what we are going to do instead is add the different information we'll need from this file to our Firebase environment variable. Let's see how we can do that. Right now we're in the Firebase documentation, and this is the part for environment configuration. So when we scroll down, we see that this is the command to run if you want to add a key to the environment variable on Firebase. We'll run this command on our terminal. So Firebase functions config set, then the name of the key, some service.key. So for example, when we come back to where we have project information, we have the project ID, which is REST API journal. So if we were to save that in the environment variable, we're going to save it as project.id. So it should be namespace using period, private.key, project.id, client.email, client.id, and so on and so forth. Now back here, we're going to copy this code sample and then we'll paste it on our terminal and edit the information there. We're back to our terminal. Now let's paste the code we just copied. I'm going to expand this so we can see it more clearly. Alright, so the different information we need for our application are the private key, the project ID, and the client email. Let's first of all get the private key. So that's this on line 5. We're going to copy from here and I'll just go to the end of the line. Then I'll copy this. Next thing we'll do is go back to our terminal and paste it here. So I'm going to edit this some service.key to private.key. The API key is going to be right here, and right click to paste. We can see paste there. Okay, now that we have that, the next thing we need is the project ID. So instead of some service.id, we have project.id. Back to our code editor, we can see our project ID right here, REST API journal. So let's copy that and then we'll paste it right here. So I'm going to remove this client ID and paste the project ID. Remember, I'm recommending this so that we don't expose this private key, this sensitive information to the public. Normally what you see in the Firebase documentation is using the file directly in our code base. So we have the project.id. The next thing we'll need is the client email. So client.email and then equal to let's get the client email. So that's this one right here on line 6. We copy that, we go back to a terminal and paste. Awesome, look at that. So let's enter. Okay, we've successfully added that. Now that we have the information in our Firebase environment variable, we can go ahead to delete this file as we won't be needing it anymore. So let's close it. You can delete it later on. The next thing we're going to do is create a Firebase configuration file. So to do that, let's come over to the src folder and create a new folder named config. And inside our config folder, we'll create a new file. We'll name that firebase.ts. So that's that, firebase.ts file. Inside our firebase.ts file, we'll start by importing our Firebase admin. So import star as admin from Firebase admin. Next, we're going to import Firebase functions. So we'll use these functions to access our environment variables. So that's Firebase functions. I hope that's correct. What's the problem? Import star as function. Let's see, function is a reserved word. Oh yeah, functions. Awesome. The next thing we'll do is admin.initialize app. So this initializes our application and then gives us access to the Firebase admin. Now this initialize app method is expecting an object with the credentials. So start with our credential, and then inside here for credential, admin.credential.cert, cert. I think that should mean certification. And inside it, we'll start with the private key. So private key, and then to access our environment variable for the private key we stored earlier, functions.config.private key. Let's clear this up so I can see what I'm doing. So private.key, remember it's namespace with the dots, the full stop. So private.key. And what we're going to do next, remember our private key has so many words and has like different new lines in it. So we are going to use regex to replace those new lines. So it has a new line with something like this, double backwards /n, and then let's replace that with just this. If we don't do that, we will receive an error. So you can try it out without this dot replace method, and then you should receive an error. So this is the key dot replace. So we're just replacing the double /n to /n, and then we have the next one, which is project ID. So project ID functions.config.project.id. Okay, so that's for that. We'll also need the client email. So client email functions.config.client.email. Okay, so that's that. Now we have that. We'll also add the database URL. This is still in our object. So this is still in the object's arguments we are supplying to the admin.initializeApp method. So database URL, and then what's a database URL? So that should be HTTPS. What's the name of our application? That's REST API journal. So REST API journal.firebase.io.com. So the database URL is usually the name of the project.firebase.io.com. Now that we have the database URL, we've initialized our admin. The next thing we're going to do is get our database. So to do that, const db will be equal to our admin.firestore. So that's a Firestore database. Now finally, let's export the admin and the db. We'll be needing them both. We have that. We have a firebase.ts file configured, set up. Next thing we're going to do is use it. So back to our index.ts file, what we want to do is create a controller file so that we can have the different controllers for adding information to a database, files to database, getting information from it, updating and deleting. Instead of writing everything inside the index.ts file, let's just create an entry controller.ts file. No, we should do that right inside the src folder. So new file, then entry controller.ts file. So we use this to write our different controllers. Now inside our entry controller.ts file, we'll start by importing our response. So that's the response type, and we'll import that from Express. The next thing we're going to do is import our database db from, so this is /config/Firebase. Now that we have that, we want to declare a type for our entries. So this is with a type keyword, and then let's name this entry type. Our entries should have a title and a text, so let's just use those two. So the title is a string and the text is a string. Let's also create a type for our request. So we have the type for response, we'll create the type for request, and inside the type for request we'll need the body to be entry type. Next thing we'll need is params. So when we are updating entries in our database, we'll need to provide IDs. So we want to send a REST request to update a particular entry. We need to provide the ID for that particular entry. So that's why we're adding it to our parameter here. So for params, we have entry ID, and that is a string. Okay, so we have the entry type and we have the request. Let's create a function for adding entries. So const add entry is equal to, so let's make this asynchronous async, and then request is the request type we have right there, and we have response as the response type we imported from Express. So request and response, and then we provide content for our function. So let's first of all destructure the two information we'll need from the body. So that's the title and the text. So we need those two from rec.body. So that's rec.body. Now we're going to make a database request next. So we want to send a creation request. We want to tell our database to create a particular entry. So we're sending this information we have from rec.body to Firebase and say, oh, Firebase, create something in our Firestore database. What we're going to do is wrap our request in a try catch block. So we have the try, and then inside it, let's add our request. We'll start with the const entry, and this is so that when we have an error with sending information to the database, we get our error message. So const entry is equal to db.collection. So you remember we imported our database right here on line 2. That's db.collection, and then entries. So what are collections in Firestore? So Firestore is a non-relational database, and it's similar to MongoDB. You have your collections, and in those collections you have your documents. So we want to create a new document for our entry, and to do that we'll have to specify the collection where we want to create that document. So this is the entries collection, and then doc. This is creating the new document. So what's going to happen here is that Firestore will look for a collection named entries in the database, and if it does not see any collection named entries, it's going to create one for us and then create that new document in it. So we have a new Firestore document. What we're going to do next is create our entry object. So this is what we want to put in the entry. Remember, we just created the document. Now we want to create the object we'll be putting in the document. Now our entry object has an ID. So the reason we're creating this document first of all before adding the entry object is so that we can also include the ID as part of the document information. What we want is that when we fetch a document, it should come with its ID. To do that, we'll have to store the ID inside that document. So right now this document is here, the document has an ID. To access the document ID, you have to do this entry.id. Entry.id will give us this particular document ID. So let's use that now. This is the entry object, And inside our entry object, we have the ID, and to access our ID, the document, that's entry.id. So we have that, and then we have the title, and we have the text. All right. Next thing we're going to do is use the set method to update our entry. So entry.set entry object. So right now, here's what we did. First of all, we created a new document. That's this entry db.collection entries.doc. So we created a new document inside the entries collection, and then what we're doing on line 24 is we're updating our document to this new information here. So to the entry object information, the ID, the title, the text. So we use entry.set to set information in a Firestore document. Now that we have that, the next thing we're going to do is send over our response. So that's response.status, and it's 200.send. Remember, this is in a try catch block, so we are assuming that this is successful. If it's successful, we have this. We're sending this over to our user. So response.status 200.send, and then inside this we have status as success. We have a message: entry added successfully. Then we have the data, that's the entry object. So let's send that back to the user also. With that done, we also need a catch block. So that's the try, and then this is the catch. We have the error right here. We open brackets, rest.status. So we're assuming that this is a 500 error. You want to do other form of validation, like maybe user input validation and all the rest. You'll be able to do that through middleware. So since we've already set up our Firebase functions to use Express, you can easily add middleware for validation and then send a custom status response. So right now, let's assume it's 500 error, and then inside that JSON response we have the error.message. Okay, with that done, let's see if we have any red lines. No, there's no red line. All right, let's export. And next we'll go back to our index.ts file. Let's import the add entry function. So import from, that should be entry controller. Then we'll see what we have here. That's the add entry function. Next, app.get. Remember, this is like working with any other Express application. This is entries, and okay, what I want to do is posts rather. So app.posts and entries. This is the function add entry. If we were to add any other middleware, we can do that just before here. So validate user inputs, and then send a custom error with that middleware and all the rest. So this is our add entry right here. This is the route app.posts to /entries. We have the add entry function. Let's save that and redeploy our application. Back to the terminal, we have npm run deploy. To test this, we'll need a REST API client like Postman. You can come over to your browser and search for Postman. So that's Postman. So you have Postman, and then click on the first link you see, probably www.postman.com. Then install Postman, set it up. It's pretty straightforward to set it up. Alright, with Postman installed and set up in our computer, we can go ahead to make a post request. First of all, what we're going to do is go over to the Firebase Console, and let's get the URL for our application. So this is the URL. Copy that back to the Postman application. We'll paste that in this URL bar. So this is the place we paste our URLs. Instead of get, what we want to do is post. We want to make a post request. So we have this, and then we have this. Let's come over to the body section, and we'll use the X form URL encoded to send our request. So for this, we need the key value pairs. We need title and we need text. So let's have title before text. So we need the title and we need the text. Okay, what's our title? Let's say my very first entry. So my very first entry, and then for text we can use this is my very first journal entry. Okay, then click on the send button. See, we have an error, cannot post, and that is because when we come over to our URL, we're supposed to be sending this request to /entries and not just /app. So this is what we specified in our code, /entries. We're supposed to be sending the post request to /entries. Now let's send this request again. Nice. Success, entry added successfully, and we have our entry ID, our very first entry. This is my very first journal entry. What we're going to do next is try sending this without the text field. So remember, the title and the text field are required. So let's try sending this without a required field. We click on the send button, and you see that we have an error. Value for argument is not a valid Firestore document. So these are catch block in action. That's why we needed the try catch blocks. But you probably need a custom middleware validation for this purpose, because this is returning a 500 error for us. It's not supposed to be a 500 error. This is a user request error. It's a user input error. So you probably need to catch that with a middleware before you even send it to Firestore. Now that we've created our very first entry, let's go back to the Firebase console and see the information we have in the Firestore database. Back to our Firebase console, we'll click on the Firestore section, and you see our database. So we have the entries collection created for us. We have a new document. This is the document ID, and then you have the fields. So normally, if we had not added the entry.id as part of the fields, we'll have just text and title, and then we can see the document ID here. But the problem would be that we won't be able to access this document ID when we send a GET request for our entry. That's why we needed to add the ID as a field in the entry body. So we have our very first entry. Now we've been able to post information to our Firestore database. Let's see how we can get information through our Firebase functions. To create a function for getting entries, we'll go back to the entry controller.ts file, and right beneath the add entry function, let's create a new function. We'll name that get all entries. So we use this to get all the entries in our Firestore database. So get all entries, and then this is a function. Our function parameters are, remember, we need the request and the response. So let's copy this and paste it right inside here on line 36. Okay, we have that. Let's add information for our get all entries function inside the try catch block again, and let's add the catch immediately so we don't forget. So the catch and then the error, this should be return arrest.status 500. Let's move this to a new line. So that's return res.status 500.json and error.message. Okay, we have our catch block. Now for the try block, this is our all entries variable. We are going to create an all entries variable. This is where we'll store all the entries we're getting from the Firestore database. We want to use the await keyword here to get entries from the database. So to do that, we'll have to make this function an asynchronous function. So async and then await db.collection. We have an error. We'll check out what that is in a bit. So we have entries and .get. Okay, so .get is used to fetch data from Firestore collection. So we're trying to get all the documents in this entries collection. Let's see what the error is. So cannot find name async, async, and this is because we have an extra parenthesis right here. So let's remove that. You see that the error is gone. So async, the request and the response. Now we have all the entries inside this particular all entries variable, which we've gotten from the db.collection method and then .get. What we're going to do next is return. So rest.status and then 200.json, so the JSON and all entries. So we have all the entries, right? But we want to access the documents in this all entries variable. So all these entries from the collection, to access the documents in it, we'll use the .docs property. So .docs should give us all the documents in our all entries collection. Now that we have that, we have the catch block, we have the try block. What we'll do next is export our get all entries function. So get all entries, we'll export that and go back to the index.ts file, app.get /entries. So the difference is the one on line 8 is app.post and this is app.get. So /entries and gets all entries, so that it's automatically imported for us. Now let's redeploy our application and test it out. Deploy complete. Let's test it out with Postman. Okay, so instead of post, we're going to use get. So select get and send. We have an error message, 400 bad request. Let's try that again, but without the title. Send. And see that we have a response. So look at our entry. This is my very first journal entry, my very first entry. So that's the title and this is the text. We have the ID. When we scroll down, we see that there's something strange, and that's our private key, the information we were trying to hide. We can see it right now when making the get request. So if a user makes a get request to application, they can see that private key that we've been trying to hide, the one we had to use our environment variables for. So how do we get that out of here? So Firebase does not have any out of the box way to do this. There's no straightforward way to do this in Firebase. What we'll do instead is filter out just this data and then remove this private key before sending the information back to the user. So let's go to our code editor. Inside our code editor, this is our get entries function, and what we're going to do is create an all entry. So this particular all entries variable, let's have it as an empty array instead. So this should be the entry type. Remember we created an entry type earlier. That's this one right here. So this is the entry type for our all entries variable, and it's an array, and by default it's empty. So what's the error message you're receiving here? Okay, so this is not equal to this is the column. So the all entry type is the entry type array for the entry array of the entry type, and then its value is an empty array. By default, we want to push the documents, the one we need, we want to push the information we need inside this all entries variable. So we're going to use a query snapshot. Query snapshot just contains our Firebase documents. So query snapshots, that's what we'll name this particular variable, and that's what we had before. Await db.collection, just what we had before. It's a query snapshot, so that's what Firestore calls it. .get, and that's a query snapshot. What we're going to do next is filter out just the data from our document and leave the sensitive information we're trying to hide from the user. So let's use the for each method. So query snapshot dot for each, and then inside this we have a doc. So this is the parameter we're giving it, and the type should be an any type, because we can't just easily get the type for Firebase document. I think that should be available somewhere, but it was very difficult to find. So we need the all entries variable and dot push, and then doc.data. So this should give us just the data we need, just the information we need. Now we have our all entries variable, and we have the data we need inside the all entries variable. What we're going to do next is just send the all entries variable back to the user. We've already gotten the doc.data from our collection, our entries collection. Now we have return rest of status 200 JSON all entries, then our catch method, And let's try this out. So we just save and redeploy. Oh, we have that deployed. Let's test it out on Postman. Oh, we click the send button, and awesome, we have just the information we need. Text, this is my very first journal entry, ID, and title. Nice. So we've seen how to post entries to a database. We've seen how to get entries from a database. Let's see how to update entries in a database and then delete entries from a database. Back to the entry controller.ts file, we'll create a new function and name it update entry. So const update entry, and then this is an asynchronous function, so we have the async keyword, then our request, the request type, and the response type. Let's destructure our text title. We'll also need the entry ID, so we'll get all of this from the request. So what we're going to do is, first of all, get the text and the title from body. Next, we'll get the entry ID from param. So remember, we're trying to update a particular entry, so we need the entry ID. Now we have that. Let's get this from rec. So that's the request. The try catch block again, and then entry, that's equal to db.collection, and then this is the entries collection dot document, and we're trying to get a particular document. So we have the .doc, but this time around we're not going to stop here. We'll include the ID for that document. So inside this doc method, we're going to add the entry ID. So we're getting this particular entry. Now we have the entry. The next thing we're going to do is update the entry. Remember, to update an entry, we'll need the .set method. So entry.set, and then the new object for our entry. But before that, we want to get the current data from our entry. So just in case the user wants to update just the text without the title, we'll get the current data. So the current title in the Firestore database, we'll get that current title and then add it to the request. Let's see how to do that. We have the current data variable, and then we're getting current data. So to get the current data, we're going to call the entry.get method. So let's put this inside the parentheses, since we want to use the await keyword. So this is entry.get, and then .data. With this, we have our current data. So this is the current data from the entry document that we've gotten from line 52. So this is data. Just in case this is not available, we have an empty object. Now we have that, let's create our entry object. So const entry object is equal to, we have the title. So this is title we're getting from our requests. If it's not available, then let's use the title from current data. So this is current data dot title. Let's use the current title in the database. So if the user does not provide any title, we'll use the one in the database currently. I will also do the same thing for text. We have text from the user, and if that's is not available, let's use the one from the database. So current data dot text. We have our entry object. Next, we are going to use the entry.set method to update our entry. So entry.set, and then the entry object. Entry.set, and then the entry object. We should do this with the await keyword, since we're making a call to our Firestore database. Await entry.set, then the entry object. Next, return res.status, status, this is 200.json, and inside this we have the status, success, a message, should be entry, updated successfully. Then we have our data, which is the entry object. Okay. So this only gets sent if this what we have on line 60 is successful. Now that we have that, let's include our catch block. So this is a catch block right here, and then error return res.status 500 .json error.message. This is the function for updating an entry. Let's add the one for deleting an entry, then test both at the same time. So we have for update entry, let's add for deleting entry. So const delete entry, this next, and let's get the entry ID. So we're trying to delete a particular entry. We don't need a body, we just need the ID. We'll get the entry ID from a parameter rec.params. That's for the entry ID. Then a try catch block. Inside it we have our entry. We get the entry first before deleting it. Entry db.collection. Remember, this is the entries collection .doc, so that particular document, and then inside the .doc method we have entry ID. The next thing we're going to do is use the delete method. Our entry has a delete method. That's the Firebase document entry.delete. This should delete our entry. Next thing we're going to do is return res.status. We have the status right here, and then message. All right, so we have that. What do we need next? We need our catch block next. Next, I will export the two functions we just created. That's the update entry and the delete entry. Back to our index.ts file, we'll add the route for those two functions. We have app.patch for update, so we are going to use patch for update, and then slash entry slash, remember we're expecting an ID param, so this is entry ID, and then we have our update entry. Next we have the app.delete slash entries slash, remember we also expect the entry ID as a parameter, and then we have the delete entry function. We'll also need to import that delete entry. Nice. We'll save this and then redeploy. We have that deployed. Let's test a new function. Back to Postman, we'll need this particular ID to be able to edit or delete it. So we'll copy that ID and then slash entries, still the same URL, but this time around we want the patch method. We have the patch right there, and we'll need the body. Inside our body section we have the title and we have the text. This is my very first entry right now. Let's make this my updated first entry, and then this is my updated first entry. Okay, first journal entry. We have an error, cannot patch to slash entries. Remember, our application is expecting an entry ID param, so this is slash the entry ID we copied initially. Then click on send. Awesome, look at that. Success, entry updated successfully. I used my update first entry instead of my updated first entry. I want to change this right now, but I don't want to change the text. What we can do is remove the text and then click on the send button again. Nice, look at that. We still have a title and we have a text. This is why we have to include the information from our existing document. Now we're able to update our entry. Let's try to delete an entry. So this particular entry, the URL remains the same, but instead of the patch we'll need the delete method, and then let's remove the body. We'll click on the send button and look at that, entry deleted successfully. So let's try to get all our entries and see if we can still find that particular entry. Click on the send button and it's empty. So we've successfully added an entry, we've successfully updated that entry, we've successfully fetched that entry from the database, and we've successfully deleted the entry. So we're basically done with our Journal REST API. Remember, like we discussed in the course of building this application, we'll need to add extra validation, extra middleware, and you can easily do that by adding whatever middleware you want to add before the function. So right here on line 8 you can add a new middleware and then add entry function. So you can also use this to authenticate and authorize users, but that'll be in another course where we'll learn how to do authentication and authorization with Firebase backend and Firebase front end. Right now we're done with creating a REST API with Firebase Cloud Functions and TypeScript. We can get, we can post, we can update, and we can delete. This has been a good ride. So you can check on my YouTube channel for any updated content on Firebase, the Firebase authentication / authorization course. And we can also decide to install the Firebase console locally. So let's say we want to avoid redeploying every time we make a change to a Firebase application. We can install the Firebase console locally, and you can see information on that in the Firebase documentation on how to install the Firebase console locally. I'll also create a video on that, so you can check back in my channel to see if I've done that. For now, we're done, and I'm really glad we took this course together. And if you enjoyed this course, please do me a favor and subscribe to my YouTube channel. That's youtube.com/EbenezerDon, youtube.com/EbenezerDon. I'd really love that. All right, see you in my next video.